Now let us talk about stacks and queues. They are very basic data structures, and they are implemented quite fast. And most of the algorithm and computer system, they have them inside. So it's very necessary that you should learn it and understand it carefully. At first go, you will understand that okay, it's very easy, but it's not like that, because once you are using these queues and stack to implement more strong data structures and complicated, then you will understand that knowing this is good. Okay, first in first out, queue. The way we stand in a queue, okay, the first person who has come, he will take the first position, and the last person who has come, he will take the position just behind this one. And we can have, or we can presume, three functionalities over it: adding an element on the last, removing the element from the first, and looking at the oldest element. Again, the looking at the oldest element, that is this element. And we can also visualize it like a conveyor belt. We place elements. This is also a kind of queue. And more closely to computer science people, printers. Printers also takes a document which has been sent by various users. So it makes a queue, and on the basis of queue only, it assigns the printer or printing function to the requested printing jobs. Also, this piling papers, boxes, stack of boxes, papers, these are all the examples of the stack. We have not seen that in various marriage parties there are various plates being kept one over another. So this is now we are talking about stack. In stack, there is a basic difference between stack and queue. What is that? In stack, the person or the plate which has been kept recently will be taken out recently, will be taken out at the first. So the functionality which we can look at is adding an element, removing, or looking at the most recently added element and removing the most recently added element. And most closely or close to the people who are with programming, those variables or program variables which are not kept in heap, these heap are for dynamic memory allocation, but others all are stored in your stack only. So this is how you may know that how important is your stack. But always see that there are real life example of stack also. Hiring and firing, the person who has been serving for most of the time will not be laid off. Rather, the person who has just joined may be given a pink slip. So stack, let us implement it first. And very closely, we will talk about stacks and recursion. Because internally, stacks are used internally by the compiler for implementing recursion. So let us see that a stack stores element of some type T. T can be any type. So we can have adding an element like push. Push means pushing an element to the top. And looking means finding which one is at the top. This is exactly same as the finding the oldest in the queue. And removing the top means removing from the top. And it's very good idea that you always have this is empty function, because if the stack is empty, and if you want to pop out an element or take out the element, there will be an error. Okay, so you need to be very sure about these problems which can be confronted by your programming sequence. So let us define this stack more formally. A stack is either stack or it forms as dot push data, means pushing a data into this stack. This is a recursive definition. As I suggested, that stacks and queues are very easy, so you just need few lines to implement them. This is not very true with queue, because in queue you need or you have more considerations than stack. So try to look at any fault, like once while you are doing with stack, always see that you don't push if the stack is full, you don't pop if the stack is empty. For example, let us take a problem of matching the parenthesis, closing parenthesis, brackets and braces. Those who might be programming right now, they know that when they compile, they are being shown by the compiler or IDE that okay, your braces are missing, or your round brackets are missing, square brackets are missing. How the compiler does that? On the background, they use the facility called stack only. And let us see this one. This is correct because you have a matching. You can say tokens, but in this case you are not matching. Either it should be a square or this should be a round bracket. In the same way, this is also incorrect. So we need to find out the incorrect by, let us implement an algorithm. How do we implement it? Let's start by an empty. We start by an empty stack, and let us see this. Okay, let us do this one. What we'll do is we will push the first one from the left, this round bracket first, and then what we are going to do is we scan for the next one, and we see that it is this square bracket. Okay, so we again push it. Square bracket will push it. All parentheses, bracket and braces are to be pushed, and we now encounter what? We encounter A and B, which is what? They are letters, so we ignore them, and then we again try to find out the next one, which is this square bracket. Okay, square bracket, and we match always the coming this token is matched with the previous one. So if square bracket is coming, we'll match this, and if they are matched, we'll pop out this. If they are matching, we'll pop out what is on the stack. But if it doesn't match, there will be an error, because once this is okay, but now as the next one comes, this one comes square bracket, it will not match with this round bracket because already these two are not matching. So this will be a problem. So this is a rudimentary parser. You will find it in many IDEs, compilers, parser. This is how we implement a short algorithm using stack. So now you can understand how important is stack and queues for your programming and for your data structure. Okay, and always try to see for any type of error that may creep in, so that you will have a good program or data structure. Thank you so much. Take care.